So this is Computer Science 305, Programming Languages, and we're talking about scope. And we're continuing on, this is part 2, scoping with label namespaces. And so, label namespace, if we programmed in Java, C#, C++, they have we have labeled names spaces, right? So it's a label namespace is any language construct that contains definitions in a region of that program where those definitions apply, and also has a name that can be used to access those definitions from outside the construct. Packages inside Java are one of the easiest to understand ways of thinking about this. ML has one. It's called a structure. So ML structures, right? I can create a structure. We'll call it Fred, and then I can say within. So then you say Fred equals struct, and then within this, I can make all sorts of definitions. I can create functions, and it goes until the end keyword for that struct, right? So it's like a block, but larger in scope. Here A can be used anywhere from the definition to the end, right? Because we define the value A within this structure, so it can be anywhere within this structure. But the definitions are also available outside, so I can actually access this. So I can access Fred.A, Fred.f, the function, right? And the beauty of this is, just like in Java, it gives us the ability to have not only access to all these things that we create over here, but allows us to have our own set of names that are contained within the structure of Fred, just like we can have our own set of names for types and things like that within packages in Java, right? And so Ruby also allows this. I can't think of any modern programming language that really does not allow this. Other label namespaces, as I've said, C++ has the namespace. Modulo 3 called it a module. Ada called it a package. Java calls it a package. C# calls it a namespace. Namespaces also serve other purposes, right? They in object-oriented languages, they provide locations for class definitions. And specifically, this is for class-based OO. Prototype-based OO systems like JavaScript do not necessarily need this, but I believe even the most recent JavaScript specifications allow for namespacing. But don't quote me on that. It's been a while since I looked. And so, for example, right, we have the public class month, right? This is obviously Java. We create a public static int min and another one max, right? 1 and 12, right? The variables min max would be visible within the rest of the class, but also accessible from outside, right? And they're scoped to the actual class itself as constants rather than as participants in one of the objects. So the interesting thing is classes inside a language like this also serve a different purpose as well. Namespace advantages, right? So there's two major conflicting goals going on here, right? So typically what would be going on is that you'd have to provide, without namespaces, you'd have to have some memorable name, but simple, for your variables. You want simple names, but you want them to be memorable, so that you could use them over and over. And then for globally accessible things, you want to use uncommon names like max, apply, or bid here, names that will not conflict with other parts of the program because they're going to be at the global scope, right? Those are the two problems that we normally would have. Think of in C, right? C doesn't have namespaces, or for the longest time did not, and it prevents you from you have to have completely unique names all the time when you're building up your system, and so you have to know what you are not going to conflict with. Well, that's never a good thing, and it leads to nasty looking naming schemes and things like that. But when we create namespaces, like in Java package system, you have this ability to construct literally a space for your names. That's kind of where that word comes from, right? And so what that allows you then to do is you can have short, simple names, They're also uncommon because you create your own namespace on which these names exist, so you build them up so you have a full identifier, thus preventing them from conflicting with any other parts of the program, which is awesome. So most namespace constructs have some way to allow part of the namespace to be kept private, right? Interesting enough, up until Java 9, this was not true. I believe now that you have the ability to privatize parts of a namespace. And I say this when we're looking at types, right? We can always privatize parts of a class to keep that away from other people. And that's part of good class design. It's called information hiding, right? Which is not necessarily refined only to object-oriented, but it's where you most often see that. But namespace refinement does allow us to privatize certain parts of the code so that not everything can be accessible from outside. When we do this, right, that ensures a more maintainable system because we provide only access to the parts that we want anyone else to change, right? And for example, if we're thinking about this inside of object-oriented system, we typically, for our variables, privatize those and make public accessors and mutators if we want, right? We want to control who has access and how it's done when we modify our internal components for classes and types. Well, the interesting thing is that's when we also want to and that kind of gets into this, when you start thinking about abstract data types, right? You took the data structures and algorithms courses, and so abstract data types, right? If we design them correctly, and we design our systems correctly, our type systems, we design them such that we create a strict interface by which we guarantee, so it's like a contract, which allows us to have more concrete types, but hide the implementation details in those, and privatize that information so that it's not generally accessible to the other parts of the program. So, for example, right, if we're looking here, we just have some definition, right? Namespace dictionary contains, and inside of here we create you have the constant for its initial default size. You have a definition for a type definition called hash table, function definition for hash, right? Because we want to be able to hash things. We have a function definition for reallocation, right? So that we can reallocate memory as well as move things around inside the hash table, so we can compact it in size. Furthermore, we have basic operations on which we can do things. We create, insert, search, and delete. And those parts of the information, that part is visible. We want the rest to be hidden because we don't need the users of our ADT to be able to see how these things work. We don't need them to understand the very low-level details of the dictionary and the potential of them accessing and possibly damaging the data structure in memory while it's running. We don't need that. And so we create only certain avenues for them to access and manipulate the system, which is just good design. So there's two different approaches for doing all this, right? In some languages like C++, the namespace specifies visibility of its components, right? So in other languages like ML, a separate construct defines the interface to a namespace. We call that a signature in ML. And then other languages like Ada and Java, right, we combine both approaches. So you have some part in Java, right, the entirety of the namespace, the package, up until version 9 was, or unless you were using, there were some other techniques like OSGI, which we won't talk about in this class, but that allowed you to, you can now privatize portions of the package at the package level. So you can actually make inner sub-packages and things like that are implementation details. You can make them private to the outside world, so outsiders looking at your module, which is like a jar file, versus what used to be where everything is just open. Then you had at the class level, I can privatize classes and I can privatize the internal components of classes, but I can't do that to every single one, and I cannot privatize sections of a package or packages themselves from access through the jar. So that's an issue with Java that's been rectified only like 15 years after we've all were requesting it. But in C++, we have the better ability to privatize the namespace itself. So interesting as that is. So in namespace, right? So namespace specifies visibility. So namespace dictionary contains, and then we can define private or public, right? So we have the private components, which, as we stated earlier, were the things that we want. These are the internal components that define how the internal workings of the dictionary work, as opposed to the public interface functions that we want to keep visible and not hide the details, right? So, and this is exactly what we want. We just want to be able to provide different levels of privatization. So, the other interesting thing is we can actually define interfaces, right? This is basically how object-oriented thought and design works, right? We create the separate interface that is a definition, but not a specific implementation of the dictionary. And then what we want to talk about is, so that tells us here's the exact details on what you want to do. And then we have our own specific concrete implementation called My Dictionary, which then implements it using a hash table. Another way would be using like a tree or several other different approaches. But anyway, you can... and this one will then have to create the define the private section of its within that namespace My Dictionary. So the next area, right? So that was labeled namespaces. There are other concepts known as primitive namespaces. So, right. So let's say we have val int equals 3, right? If we try to do that in inside of ML, what it would do is it would cause an error, right? Because you're trying to say that we have some int is equal to 3 of type int. It's not going to understand what you're trying to say. It gets confused. You can you can do the next section, which is like you have some function f, which takes a value int and equals int times int, right? It will determine that what you're doing is not actually a problem, right? You can have, sorry, I misspoke there. It is legal to have a variable named int. You can do that. ML doesn't become confused. The reason it doesn't become confused is not because these are keywords or anything like that. These are in their own namespace in a type, right? So it keeps so ML syntax keeps types and expressions separate. ML always knows whether it's looking for a type or something else. So when we're looking at this, right, we create a function that takes in an int. It knows what that is. It knows it's a variable. It knows that that's not a type that you're specifying there. But the interesting thing is the way it does that is it allows you to we can actually specify the type using the colon operator, right? And so that would then give it a what we would call a primitive namespace, right? So interesting as that is, but and int itself is inside its own namespace, the namespace of types, right? Types and expressions are separate, as it says above, and that's how it allows us to do this. Although I would not suggest doing that because it does make it hard to understand what's going on for the human, not for ML, but for the human, and reduces the readability of your code. Primitive namespaces are not explicitly created using the language, like primitive types. They are part of the language definition itself. And so, some languages have several separate primitive namespaces. For example, Java has separate primitive namespaces. The notion of packages, types, methods, variables, statement labels are all in separate individual namespaces themselves, but also have we're not going to quite get into that, but I'm going to leave this where it is, and I'll cut it off here, and then we'll have a third part which is on dynamic scoping and separate compilation.